Hey, welcome back to Gold Scratch. So today we're going to talk about some automotive engineering, and I'm going to simplify some important factors relating to that everyone needs to know if you're going to rebuild your own engine, and that is the subject of tolerancing and how tolerancing properly applied can give you a better engine, make it last longer, and all that kind of stuff. So one of the definitions of blueprinting is measuring every single important dimension, documenting it, recording it, and then taking action if those measurements are not within the specification that you want, which are usually a better specification than the OEM specification. However, when your OEM original engine was made in the factory assembly line, they made hundreds of engines a day, and they didn't measure anything. And could you imagine if they stopped to do what we do, that no one could afford to buy a car? So if you understand tolerancing, you can apply it properly and make sure that you're going to have an engine that's going to have long life. So we're going to use a real example of the crankshaft in Al Rader's 454 LS7 engine. I got some exhibits here for you. I got the dimensions. We're going to focus on the main bearing clearances and tolerances. I'm going to explain how that works and then show you all the dimensions that we take in order to have a successful engine. So let's start with a couple of very important definitions. First of all, a tolerance is the allowable variation plus or minus for any dimension, in this case in your engine. So let's take, for example, the crankshaft in the 454 LS7 is 2 3/4 inches, 2.750. Well, it's absolutely impossible for any dimension to be exactly 2.750. So in manufacturing process, there's always an allowable upper limit and lower limit that could be. And when we get over to our charts, I'm going to show you exactly what that is. Then that's tolerance. Now the next one is, what is the allowable clearance? Clearance also has variation. And in the case of Al's 454, the manufacturer's recommended clearance or allowable clearance is 0.0013, 1.3 thou to 0.0025. That is the tolerance on the clearance. So the clearance has a tolerance as well. What's the allowable variation plus or minus on either side? And so when they designed the factory assembly line, what they do is they don't measure anything, because as long as they know that the crankshaft is within that tolerance that I'm going to show you. Might as well get you come in here, Alec, and I'll show you right now. So there's the crankshaft. So even though the main bearing journal crankshaft nominally is 2 3/4, it could be anywhere from 2.7481 on the low side to 2.7490. So almost a thousandths, 9/10,000ths of an inch variation. Okay, and then the main bearing clearance, factory OEM, is 0.0013, 1.3 thou, to 0.0025. So it could be as low as 0.0013 to 0.0025. So when we blueprint an engine, we do a couple things. Typically, we add more clearance, a little more clearance, but you have to be careful. You can't add too much, and I'll show you why. So if the clearance is too tight, okay, then 0.0013 would not be acceptable for Al's 454, because if you have 0.0013, that's not much clearance. The oil can heat up too much. There's not much space. It can't support it. And in a high stress situation, the crankshaft may touch the bearing, and once that happens, it's game over. So let's look at that application right here. So what I've done is I've drawn, so that the only thing I painted sort of is the yellow line, or the orange line, I guess it's orange, and that is the oil flowing. That's your crankshaft journal. This is your bearing here. That's your crankshaft journal, and that's the oil film. So the tolerance, the automotive tolerance, factory tolerance is, if we have the largest crankshaft journal, that's 2.7490, going back here, that's the largest size. And the smallest bearing, okay, then we only have 0.0013 of clearance. And now, remember that clearance is divided by 2 because half of it's got to be on each side of the bearing. When you take the dimension, the difference is 0.0013. So only half of that is on each side. So the film of oil between the bearing and the crankshaft journal is less than 1/1000th of an inch if you follow the factory tolerance. So in the factory, they're okay with that. And there's lots of engines running around with 0.0013. They're doing fine. So the next side of the factory tolerance would be if you had the smallest diameter crankshaft, 2.7481. So if you go down here, that's the minimum size, 2.7481. And the largest bearing, smallest crankshaft, and the largest bearing, then you will have 0.025 clearance, plus or minus 2. Again, half of the clearance is on this side, the other half of the clearance is on this side. So that's more desirable. So the other thing is that you have a variation from 0.013 to 0.025, 12/1000ths of an inch allowable variation. So in blueprinting, we do a couple things. We want a little more clearance, and we don't want as much variation. So that's the OEM, tightest and loosest side. Now, if you're too loose, what can happen is there may not be enough oil volume flow. Oil pumps don't make pressure, they make volume. The pressure is created when you have resistance. There wouldn't be enough to support the bearing. In an ideal world, the crankshaft journal never ever touches the bearing. In reality, it doesn't, and it shouldn't, other than on instantly after startup maybe. Because when you shut down, the crankshaft may sink into the bearing. But when it's turning, it's going to be off that bearing. So that's how that should work. However, if you look what we do when we blueprint, I don't want to have a range of 0.013 to 0.025. Ideally, for an application like this for Al, 0.025 to 0.030 is an ideal clearance for a main bearing for Al's 454. So over here is what I've done. Now, I've blown this up, so this sheet is the total chart of all the dimensions I've taken on Al's engine so far, and we're not done. We still got work to do. These clearances shown down here are too much, so I've actually ordered undersized bearings in order to correct that, because that clearance is excessive. So this block here is blown up to be this block here. So here's what we've done now. So there's the crank pin dimensions. So I've taken an average of them, 2.7486. And there's the clearances. I do them with the dial bore gauge. I'll show you that. 0030, 283027. Now I've only shown main bearings 1 to 4 because number 5 main bearing has a different specification. Why is that? Because number 5 main bearing is wider, so typically it has more clearance. But focusing on 1 to 4, there is a specification for the crankshaft journal. Once again, I already mentioned that. That's exactly what I was talking about. And now my clearance, there's a specification, but my range is only from 0.27 to 0.30, okay? So the average specification is 0.0019. My average is 0.0029. So I've actually got a thou more average clearance and a shorter range between the maximum and minimum. Here there's 13 thou. Here there's only 3 thou. So that gives you a tighter clearance, okay, in the specification, and tighter range between the maximum and minimum, and a little more clearance in the range that we want. Oh, once again, but 0.025 to 0.0030. So hopefully that makes sense. Now, one of the things that's important to know is, it's nice to know all that, but you have to be able to measure it accurately. So So there's a number of ways to measure what that clearance is. The old way, I guess, or the way that I started off using, and a lot of guys still do that, it's okay. It's a lot more work to do it that way. It's called plastic gauge, where you insert a little bit of, it's actually a little piece of plastic between the bearing and the journal. You torque it down to spec, and the width of that dimension is measured when you take the bearing cap back off and measure it. But there's better ways, and probably worth thinking about, and that is a dial bore gauge. And if you have a dial bore gauge, you need a micrometer. Now, for some, this might look intimidating. These are not that expensive, well under $100 anyways. But, and of course, if you're going to have a dial bore gauge, you need a micrometer to measure off. So here's the reason why. When we measure the clearance that we're after in this journal, we don't even care what the dimension of the crankshaft is. We measure it with the micrometer. You can record it if you want, and I do, okay, but you don't have to. You put the dial bore gauge in there and zero it, and when you put that into your bearing, and I've showed this in previous videos, I don't have one apart right now to show you, but when you do that, it tells you the clearance. That's all you need to know. So it's, in this case, between 002 thou and 0225, 0030. As long as it's in that range, we're good to go. So how it works is this, there's a little prod here. When you insert that into the bearing and rotate it, it rotates this little guy, and that tells you how much difference between the bearing space is and the crankshaft journal that you measured. Hope that makes sense. So that's the way to do that accurately. And of course, the way I do it, and I'm sure every professional engine builder does it, it gives you accurate measurement, also a lot faster than plastic gauge. If you go back to the other old days, we used to measure the bore with one micrometer, measure the diameter of whatever the piston or the crankshaft with another, and subtract one from the other. Obviously, lots of opportunity for error. The two measurements and then the calculation. Whereas a dial bore gauge, pretty simple. It doesn't really even matter what the dimension of the crankshaft is. The only thing that matters is what the clearance is. So that's applied to every important dimension in the engine: the main bearings, rod bearings, the pistons. Piston clearance is measured exactly the same way. You measure the OD of the piston, and they use the dial bore gauge in the bore, and that tells you what the piston clearance is. And I think there's another one. I had to go to my cheat sheets here to see if I can remember what it is. Yeah, a couple other things that we measure: the crankshaft thrust clearance and the camshaft thrust clearance, which not with the dial bore gauge, but with the dial indicator as well. So these tools are not expensive. And when you consider what you're going to spend on building your dream engine, probably worthwhile investing. Do a little practice with them before you get going, and you'll find you got better results. So hope you found that interesting. All the dimensions that I used here came out of the GM manual. Didn't make anything up. Those specifications are for a big block Chevrolet 427, 454, or whatever, right out of the GM manual. So, and that's how it works. We're really happy with the main bearing clearances that we got. Usually a machine shop that's machining crankshafts. In this case, we didn't get the crankshaft machine, but we'll machine for a little extra clearance. If you don't have it, and in some cases in the case of the rod bearings, we got work to do. Once again, that's blueprint. You measure, and if it's not right, you take action to fix it. So we got too much clearance, so we're going to fix that by, we got a set of bearings that are ordered that are 1/1000th less clearance than nominal or than standard, and that'll fix our connector rod bearing clearances. Hope you found that interesting. So there should be a video out by the time you watch this one. This is Clarence Washington's 389 Pontiac out of a 64 Pontiac Bonneville 2+2. we made a video of that previously, so Mike should be getting that up before you see this one. We haven't touched it yet, and we're not going until we get some other things out of our way. Still waiting for valve lifters for Mike's 340 Mopar. We'll get that done, and we got dyno dates scheduled. 2 dyno days scheduled in February and March. We got 3 dyno days. One for this one for that, and one for Al's 454. So lots of action coming up. Hope you found that interesting. Please help me by liking and subscribing. Subscribers motivate me. That's my psychic income. Okay, so if you subscribe, like, share, the longer you watch it, the more you comment on it, the more YouTube says, hey, this is a pretty good video. Let's show it to somebody else, and that's what keeps us going. Thank you very much for watching Gold's Garage.